Last time I promised you to tell about a novel way to do rotoscoping. In the past, this was hard work. We don't want to trace a still frame on a fluorescent tube anymore. But what are the other options to do rotoscoping in modern days? The traditional process of tracing individual pixels over video footage is tedious and highly labor-intensive. Oh, sorry, I forgot to blur the offending bits here. Another problem is finding the right video reference with the animation you intended to portray in your game. Okay, so where am I getting at? The general idea is to have a frontier model to render the character as a real person and then have this person perform the animation you want. Hey, a rock just appeared. Let's pick it up.
Arr, matey. Do I need to remind you that we need pixel art?
Yes, pixel art, that is what we are after. So we need to post-process this ultra-smooth, high-res footage into some pixel art rendition and not with a gazillion colors. Oh, and do we really want this butt crack to appear in our animation? With an open source video generation model and this sample image and a prompt as input, it is possible to create a source video for my rotoscoping process. So, for instance, if I want an idle animation for McMarcus, like scratching his butt, then I could try out many prompts and pick one that works best. Besides the costs of video generation, going local on video generation with such an open source model frees you from the annoying denial of service errors because of forbidden word detection. A term like scratching butt or picking up will lead to rejections, even if the context of the words is harmless. An animation like banging head is nearly impossible. Okay, enough complaining. So how did I get from the high-res footage to the intermediate pixel art stage? The quickest way to help me achieve this goal was by letting Codex write the code for me in beautiful Python. Python is a good choice because it supports a lot of open source libraries that can help extract the right frames, detect colors, scale, and export the resulting frames to disk. I have shared the project on GitHub in the descriptions below. It would help if you start a project if you find it useful or inspires you to make a tool like this yourself. Although the code made is not mine, it is still a great idea. And the goal was to make games, not tools. This frees up a lot of your time. So, with that out of the way, a few tips on creating a video generation prompt that provides the best results and some tips on how to use Comfui and LTX2. The most important thing about getting the right prompt is to think about the following properties of your video. One of the most properties is to define a static camera. The fact that the character should stay in frame at all time, and that the character should stay stationary and move in a stationary fashion. I often had a flawed prompt and that did the animation perfectly, but it only showed a small part of the body instead of the full character from head to toe. So in this example prompt, you can see 3 sections describing different setups of your shot. First, the context in how the character should move. Second, the constraint that the character should be in full view. And lastly, the lighting conditions. In this case, we want the most boring light. And also the least cinematic video recording that we can manage. I will not tell you how to set up the LTX2 video generation with all bells and whistles, but instead of that, I will tell what you need. A grocery list, if you will. You need a Hugging Face account to download models that take up quite some space on your hard disk. A capable laptop or PC tower. I can guarantee you that you need at least a machine with 32 gigabytes of VRAM, and that is still quite beefy. But that is the price of freedom. A Mac setup is a little bit more work, but an NVIDIA GTX 3090 or better is recommended. You need to check out some source. You need Conda or virtual environment to be able to install the many Python libraries. And You need a lot of patience, but that is also the price of freedom. And you can always tinker with a cloud version of LTX2 first. There are countless options actually. So that wraps up this big lofty promise I made in the last devlog. It will help me a lot in making countless animations for all the characters in my game. The next time I will talk about a novel way to a new kind of hint system by talking to an artificial intelligent non-playable character. I will do a deep dive on the models I used and how I got the real-time text-to-speech and lip sync integrated in a fashion that is actually enjoyable and playable. Another exciting thing is the development of my own pixel art editor for the iPad. That way I can easily integrate all productivity functions into this pixel art focused app. This rotoscoping feature might make it into this app. It will feature all standard pixel art tools that you can think of, even some new ones that will boost productivity. I think a tablet is the most productive way to create pixel art, and touch gives you a lot of creative control. Okay, if you found this interesting, then hit subscribe and ring the notification bell if you want to be notified as early as you can.